So we are continuing with section 4.2. Our focus today is going to be on solving word problems that involve some kind of quadratic function. All right. So we've dealt with the graphing part yesterday. Our focus today will be word problems. So we have some hints for you. The first one says, when a quadratic word problem references finding the maximum or minimum value of a function, it's asking for the vertex. Remember how we used the vertex to help us figure out if we have a max or a min and what that value was? All right, so if, for example, it says, how high does the ball get? All right, you're tossing a ball in the air. How high does it get? What's the maximum height? Okay, they're asking you to find the vertex. So quick review, solving for that vertex, we have to take negative b over 2a to help us find our x coordinate. Typically, when we look at word problems, we have, a lot of times we have time as our x-axis and we have height as our y-axis. We're looking at maybe the path of a ball, all right? So your ball goes up in the air. What pulls it back down?
Gravity.
And if it's not caught, it would end up back on the ground. Yes? So that's a typical type question. So our x-coordinate would tell us at what time, after how many seconds, the ball reaches its highest point, and our y-coordinate would tell us what that highest value is. Does that make sense? So if they're asking you when or where the maximum occurs, they're looking for the x-coordinate. We can then plug it back in. So now if they're asking what is the maximum or minimum, they're saying plug in that x value and find your y-coordinate. So the key to solving these questions really is to figure out that vertex. Okay. Sometimes they will ask you at what point, after how much time will the ball be back at its starting height? Okay, we did one like this yesterday. So typically we don't start a ball on the ground, right? We're throwing it, our arms up higher off the ground. So the question is, at what time would it be at that same height? What do we remember about that?
Oh, we could reflect across the...
Yeah. This point here just gets reflected over your line of symmetry and lands here, right? Because of the symmetry of our parabola, if we know how long it takes for us to get from here to here, we can just double it to get to the other side. Does that make sense? So that's not going to tell us when it hits the ground. It's going to tell us when it's back to the original height. Later on in the chapter, we'll look at when does it hit the ground. All right, so our first question. It says the height of a ball thrown upward from 5 feet with an initial velocity of 60 feet per second can be modeled by the equation h of t equals negative 16t squared plus 60t plus 5, where h of t is the height in feet and t is time in seconds. So this is just like the one I had graphed earlier. We have time in seconds here, and we have the height in feet as our y-coordinate. Okay? They are telling me that it starts 5 feet off the ground. The ball's going to go up in the air, and eventually gravity will pull it back down. Okay? This function, the setup for that is very typical when we're talking about path of a ball. Anybody know what the negative 16 is for?
Because it's your parabola going down.
That's the effect of gravity, yes. All right. The 60 in front of t, that was the velocity they told us. And the 5 they said was the starting height. Okay, but that negative 16, you're going to see that in all kinds of functions. All right, negative 16 is that gravitational constant. All right, so when does the ball reach its maximum height? Question is when. We're looking for time, right? Its maximum height is going to happen when we are up here at the vertex. So this first question is just saying, what is the time, what is the x-coordinate that gets me to that vertex? All right. In this case, we aren't using x, we're using t for time. So we need to find our x-coordinate, our t value, and we do that using that negative b over 2a. Okay, so just like we found the x-coordinate yesterday, let's plug in our numbers. We want the opposite of b. b was 60, so we need negative 60. We're dividing by 2 times our a value. So we have negative 60 being divided by negative 32. Should come out positive, right? We're looking for time when this happens. So it should be about 2, right? 60 divided by 30 would be 2. So what do we end up with? Okay, 1.875 seconds. So after 1.875 seconds, the ball will be at its highest point. Part B says, what is the maximum height of the ball? Now they're asking, what is that height, right? What is that y coordinate? So we have to plug our x value in, and instead of y, we're using h. So what is h of 1.875? Go ahead and grab your calculators. And I will give you a second to figure that out. Checking our answer here, we've got negative 16 times 1.875 squared plus 60 times 1.875 plus a 5. What do we end up with? All right. And our y coordinate was using what kind of units? Feet. So what we have found is that after 1.875 seconds, the ball will be at its highest point, which would be 61.25 feet. Okay. Part C says, when will the ball be 5 feet from hitting the ground? So again, we're looking for that reflected point over here. When are we back to being 5 feet off the ground? We know that it's 1.875 feet to the middle point, right? So we are just doubling that. So we want to double 1.875 and we get, and what units would we put on that? All right. Questions about any part of that one? Okay, our next one. It says the height of a ball thrown upward from 7 feet with an initial velocity of 50 feet per second can be modeled by this equation. Notice where the 50 and the 7 show up in our equation. Okay. It says where h of t is, again, height in feet and time is seconds. When does the ball reach its maximum height? When? The question's when. What are they asking me to find? Time. They're asking me to find my x-coordinate, basically, right? So negative b over 2a. Okay. We'll come back to that in just a second. Part B. What is the maximum height? So they're looking for our y value, right? So whatever we get for t in the first problem, we're going to plug into our function and find our y coordinate. Okay? I'm going to pause the recording. I want you guys to try this one at your tables. All right, let's check what we've got here. Our opposite of b would be negative 50. We're dividing by 2 times negative 16. What's negative 50 divided by negative 32? Okay, and that is in seconds. Now, I had a few people asking me about rounding. You don't want to round too early. If you round that first answer and then you dump it into your function, now you're going to end up rounding your height twice. Does that make sense? So you want to keep it as exact as possible. We dump that in now here. So we have negative 16 times 1.5625 squared plus 50 times 1.5625 plus 7. And we ended up with what? Okay, so if they want rounded answers, now you can round that. All right, our maximum height is going to be about 46 feet. Does that make sense? Okay. Part C, when will the ball be 7 feet from hitting the ground? So again, we're looking for when is it back to its starting position. So we need to double our time, which gets us what? Thank you. All right. Our last example is slightly different. We've done a couple now where we've been talking about time and height. Our last one says, a model for a company's revenue from selling a software package is given by R equals negative 2.5 P squared plus 500 P, where P is the price in dollars of the software. What price will maximize the revenue, and find the maximum revenue? So again, if we think in terms of our typical X and Y's, if we know R equals negative 2.5 P squared plus 500 P, that means instead of X, we're using what variable? P. So price is like our typical X value. And then what's our Y value? Do you guys know what revenue means? Revenue is not quite the same as profit. Revenue is the money you make by selling something. Profit, you'd have to subtract off your expenses from your revenue to get your profit. So there's a difference there. Revenue is just how much money that people have paid you for stuff. Okay? So it says, what price will maximize the revenue? Your maximum occurs at a vertex. So they're looking for what price, what's the X coordinate of my vertex? All right, so price equals the opposite of B over 2A. So we need the opposite of 500 over 2 times negative 2.5. What's 2 times 2.5? So we have negative 500 divided by negative 5, which is 100. So the best price, the price that will give me the maximum revenue, is if I sell it for 100 bucks. Okay? Then it says, find the maximum revenue. So what is the revenue if my price is set at $100? That means I am plugging 100 in for P. So grab your calculators. Negative 2.5 times 100 squared plus 500 times 100. What do we end up with? $25,000? Okay. I heard 2,500, but missing a zero there. Okay. So to answer the question, our best option is to sell the software for $100. If we do that, we will have a maximum revenue of $25,000. Questions on that process, those quadratic word problems? All right, so here's your assignment. Use your time wisely. Ask if you have questions.